Hello everyone, I'm Lawrence from Extrapy. Welcome to Module 6 of our Cairo Auditing course. In this module we're going to talk about security tools. We're first going to look at some development tools, so you'll need this when you're looking at a contract, you want to build it, you want to test it. And then we'll also look at some auditing tools, so we can use these to help us find vulnerabilities in the contracts. So the main development tool you'll be using is called Scarb. There's some installation instructions there. The easiest way to do this is to install it via ASDF, and that is a version manager, so it will allow you to upgrade or downgrade Scarb whenever you need to. Once you've completed the installation, you can check it was successful by running the following command you see there, and this will show you the command of Scarb. It will also display the version of Cairo and Sierra that you have. Here's a list of some of the commands and techniques you may be wanting to use. So we can create a new package with Scarb new. We probably won't be doing that. We'll probably be more interested in the second command here, which is Scarb build, where we are building some code that we already have, so the contracts that you're auditing. If you want to format it, then there's a format command there. You can also run scripts with Scarb run. If the project you're auditing has got some scripts, you may well want to do that. And there's a link there to a cheat sheet available to tell you all of the commands. The other main tool that you will be using is the Starknet CLI. So this is a command line tool that is used to interact with Starknet to get your contracts onto either the mainnet or some test nets. You will remember that when we are creating our contracts, we first need to declare them and then we deploy them. There's a link there to the installation instructions. And as always, once you've installed it, you can check the latest version. And there's a Starknet book, which has lots of details about the commands. And there's an article linked there to give you a good introduction to how Starknet works. Another tool you may want to use, if you're using VS Code, you may want to install the language server. So look in the VS Code marketplace, search for Cairo, and you should be able to find some tools there. And this will be automatically detected by Scarb if you're using that, and should start running properly. There's a link there also to the documentation if you have any problems. A more recent tool is Starknet Foundry, and this is based on the version, the Solidity Foundry version. There's links there to the installation instructions. You will need Rust and Scarb to already be installed. You can install it via curl or via ASDF. If you're on Windows, there's a link there to some instructions. Once installed, it will give you two modules, similar to what you will know from Solidity. We have the Forge module, which is used to build and test our contracts. And then there's the Cast module, which is a tool to interact with the contracts and with the network. You can check the versions as follows there, so you should see something similar to this. Okay, so that's the development tools. Let's move on to look at some auditing tools. And there are two sort of main types of these. There's the static analysis tools, and then there's symbolic execution tools and formal verification tools. Now, in my opinion, although auditing tools are useful, we're still at quite an early stage, and I have generally found that most of the issues that these tools will find for you are things that we tend to find anyway with code inspection. So when we're auditing, we tend to rely mostly on code inspection to find vulnerabilities. Of course, we use tools as well. Why not? It's helpful to have them there, and they may find some additional things. So it's certainly worth using them. But I think your focus would generally be on code inspection, particularly because some of the vulnerabilities you are going to be looking for are quite sophisticated. They may be to do with business logic, and those are more difficult for example, static analysis tools to find. Okay. So we'll go through some of them. So the first one here, Cairo, it's a static analysis tool. So this means that it will take your contract, or in this case, taking the Sierra representation, and it will then look for various patterns within the code, and where patterns where it knows there are vulnerabilities. So all static analysis tools work in a fairly similar way. They do depend on the fact that they need to know existing patterns that contain vulnerabilities. So if there's a new vulnerability, then this wouldn't be found by the static analysis tool until that pattern has been added to it. So there we've got some details of how to install the tool and then how to run it. The detectors that it has are listed here. So this is quite a useful table. It shows you the different detectors, what vulnerability it is looking for, and it's nice that it has the impact here. So this helps. It helps you when you're writing your report. You want to explain what the impact of a vulnerability is. This will help you do that. There's also a confidence given here. So this is really an indication of how confident the tool is that this is an actual vulnerability and not a false positive. And then the last column you see there shows you the versions of Cairo that this will run with. So I can quickly go through some of these. There's so this one, a high one, where we have a clash when we're calling a library. This one we're trying to interact with a layer 1, but we're not doing a correct address check. The third one here, we are not doing a safe operation with the FAL252 type. Fourth one, obviously a very well-known type of vulnerability, is reentrancy. Then we also have read-only reentrancy. Obviously, that's slightly different. The next ones are looking at unused items, so unused events, unused return values. The number 8 here, we have one where we've added a view decorator to a function, but actually that function does modify state, so we've broken that contract there. The next one, TX origin, this can be problematic. It can be the source of a man-in-the-middle attack, so you need to be very careful of how you use that, so that will be detected there. We go on to some lower impact vulnerabilities here, unused arguments. Although this may not directly be a security problem, it could be an indication that the code is incomplete. So you should always take notice of these types of issues. Reentrancy benign. So this again is an example of reentrancy. Often we find that with reentrancy, it may be detected. You may see that reentrancy is possible, but it could be that even though it is possible, there's no feasible way that could be exploited. So it's not always such a high vulnerability, but you really need to inspect the actual instance to find out whether it is going to be a problem or not. Reentrancy events, so a similar thing, but applying to events. Dead code, you should never have dead code in your contracts. You should always remove that. For example, if you have a private function that is not being used. And not only does that indicate that your contract is incomplete, but you're also creating bytecode that is not needed. So it could be an optimization issue as well. And the final one here is about the use of arrays and spans when we've removed an element that could be problematic. Now, if you want to have extra detectors, then you can add those. There's a link there to details of how you can do that. I think the examples, though, are mainly around Cairo 1, so do be aware of that. Okay. Sierra Analyzer, another static analysis tool. It is focusing on the Sierra files, as you'll guess from the name, so the intermediate representation. It allows you to decompile the Sierra file, so that can be quite useful. If you want to, if you have an intermediate representation, you want to sort of get a high-level view of that, it could be useful for that. To give you an example of what that looks like, what the representation looks like, this very simple contract would look like pretty much like this. I've cut off the end of this. There's a lot more code involved, but this is the kind of output that you would get. So it does try to, with decompilers, they do try to make them somewhat readable, but they can be difficult to read initially. So you may need to have a bit of practice at that. And then the main purpose we would want it for is to run the detectors. So you've got examples of the commands here. I've got links there to the documentation. We can also analyze a remote contract. To do that, you need to specify the contract class, as you can see there. We can get further details about the contract. For example, the control flow graph, which is useful to show you the flow through the contract. I find this useful in the approach I take to auditing. I often want to follow a particular flow through a contract rather than going through the contract line by line, at least initially. And so having an understanding of the control flow, I think, is very useful. You can output that to a particular folder. You can also print out the call graph. So this is going to show you what interactions this contract will have. Again, very useful. Often these are areas that you need to look at very closely. They could be a source of vulnerabilities, so you should be aware of those. You may find some errors where, if you try to run these relating to Z3, the SMT tool, we found that you have to be careful with the dependencies. So if you get this type of error when you're trying to run the tool, then check that you've got Z3 installed. This is some commands to install this on Mac. Obviously, you'll need to adjust this if you're using different environments. So I think this is something that you may find with other tools as well. I've come across these kind of problems where we're using something like Z3, but maybe the path isn't set up. So just be aware that you may get these kind of problems and have to get your environment adjusted accordingly. Okay, so TOLF is another toolkit which provides a number of tools, so static analyzers, disassemblers, and decompilers. So you can use this to run on the Sierra file. There's a link there to the installation steps and an article for a complete overview. Now, moving on then to a different type of tool. So a symbolic execution tool is quite different to a static analysis tool. With symbolic execution tools, what they try to do is to rely on some details in the code that indicate that there is an incorrect state. So it could be that you have some assert statements in your code that show that there's the possibility of a logic error, and static analysis tools can use those to then do reasoning and to try to find circumstances in which those incorrect states, those error states, could happen. And to do that, they provide symbols to represent the variables and the inputs into your program. So the inputs that somebody might add to a function, it tries to track those and reason about those in order to find ways that it could come to an incorrect state. There's links there to the installation and details of how to use the tool, and there's a link to a Medium article there to help you with that also. Another one is Aegis. There's a link there to the blog post. Again, this is looking at the intermediate representation and rather than looking at the Cairo syntax. This is a design decision. Obviously, we're going to be going via the intermediate representation, and so it could be that analysis of this is easier to perform than looking at the Cairo code directly. And there's a link there to the repo, so you can find the installation steps and how to use the tool from there. Finish off with the tool Horus. So this is a formal verification tool, and this is slightly different from symbolic execution tools in that a formal verification tool needs a specification of the application. So that specification will be a very detailed description of what the code is aiming to do, and it will show error states, etc. Now, one drawback to using formal verification tools when you're auditing is the fact that creating this specification is quite an expensive thing to do. There's a lot of work involved in doing it. So there's a big upfront cost to using formal verification tools. If you're going to be using this project again, if you're going to be auditing the project again and reusing that specification, then it may make sense to do that. The other thing I would say about Horus as well is that it hasn't been updated recently. I think it was written for a previous version of Cairo, so do be aware of that. There's links to the GitHub page there, so you may want to have a look at that. It's a tool from Nethermind, and one of the first tools to do verification of Cairo code. Okay, so that's a run-through of some of the tools that you may want to use when you're auditing. So I hope you found that useful, and I'll speak to you all again on Module 7. Thanks, everyone.